Welcome back so that we may continue with the example. So, y varies partly as x and partly as the square of x. So we insert the constants. So we insert a constant for the first part and a constant for the second part. So substituting the values given, that y is 14 when x is 2, then x squared will be 2 squared. And we form our first equation. Then we insert when y is 65, then we are told x is 5, and therefore x squared is 5 squared. Then you form a second equation. You will come up with two simultaneous equations. And this is common with all partial relationships. You will always form two simultaneous equations because you will be having two unknowns. Then from there, we want to make the coefficients of k1 the same by multiplying the upper part by 5 and multiplying the lower part by 2. Then use the method of solving simultaneous equations. You find that k2 is 2 and k1 is 3, and therefore the relationship between y and x is y equals 3x plus 2x squared. Looking at another example, p is partly constant. So one part of p is constant and the other part varies directly as q. So if I want to write that, maybe I write it here, you will find that we are saying p is partly a constant and partly q. Because it is a constant, I don't need to introduce another constant. So I can say p is equals to a constant, call it constant 1, plus now I introduce a constant for the variable. So introduce a constant to the variable, but when it's a constant, you leave it as a constant. Then you substitute the values given for q is 3 when p is 1 and q is 4 when p is 10. So this is what we've done. So if you substitute, you'll come up with the first equation. Then you come up with the second equation, and now you have two simultaneous equations to solve simultaneously. And once you have done that, you find k2 is 9 and k1 is 26. So the equation here now will be p equals 26, which is k1, plus 9q, and that is the relationship between p and q. To find the value of p when q is 6, then you'll substitute for the value of q, which is 6, to find this plus this gives you 8. Okay, we continue with example 3. A quantity y is partly constant and partly varies as inversely as x squared. What does that mean? Here, say y is partly a constant and partly the inverse of x squared. So when inserting constants, then y will be a constant k1 plus introducing a constant for an inverse variation will be k2 over x squared. Alright, so that is the interpretation of this statement. So substituting for the values, then we have when y is 7 and x is 10, so 10 becomes 10 squared. Now, it's important to eliminate the denominators. And how do I do it? If I multiply everywhere by 100, I multiply by 100, by 100, by 100, I'll get 700 equals 100 k1 plus k2. That is my first equation. Then what about when y is 5.5 when x is 20? So we will have 5.5 is 11 over 2. I multiply both sides by 20 squared, which is 400, to eliminate those denominators. And once I do that, I will have 2200 is equals to 400 k1 plus k2. I form the second equation. Then I organize them into a simultaneous equation and solve them simultaneously. So K1 will be 5 and K2 will be 200. So substituting in the equation, then we'll have y equals 5 plus 200 x squared. If I want to find the value of y when x is 18, then I'll put 18 here like this and get the value. All right. Now, I want you to look at this other question and try to work it out. Having done that, now you will be required to do the questions that were stated earlier. That is KLB Book 3, Exercise 9.4, dealing with partial variation. I think now we have been able to meet all the objectives that we had at the beginning: direct, inverse, joint, and partial variation. And I think now we are comfortable. Thank you very much.